All right, my friends, and so we are going to be in our next unit, and this unit, in lots of ways, is just a review. Probably 90% review, maybe 95% review. But what we're going to try to do is take the things that we've talked about and make some connections between our first unit, which was working with tables, right, and then our second unit, which was graphing and writing equations and functions. And we're going to try to merge those thoughts in this particular unit. All right, and so you can see that we're going to start with our first lesson here, which is writing equations from tables. All right, and we're going to focus on standard 1, or excuse me, standard 6.1 first in this lesson. I can write the equation of a line from a table of values. All right, so let's do a little bit of review here. All right, so let's look at our equation of a line here. So we've already talked about our slope-intercept form here. And so just as a reminder, remember there's nothing special about the equation. We know it's linear, right? So no, there's no absolute value bars, there's no exponents, all right? And that's how we know it's linear. And then hopefully you still remember the pieces. So the first piece would be, all right, what M represents. And that represents our rate of change. And I'm going to write that out here. And remember when we talk about slope and rate of change, all right, for a linear function, it is rise over run, or right, the change in y over the change in x. So hopefully you remember that from all the work that we've done, all right, over the past 2 units. And then remember with a line, this x1, y1, all right, so x1 comma y1, right, this is our starting point, all right, or just some point on the line. So with a line, we can pick any particular point on that line to write our equation. Okay, so hopefully this is just a little bit of a review. So now here's what I want you to do, all right, is I want you to pause the video and write the equation of this line, all right, just like we did in our prior unit. So go ahead and pause the video, flip it back on, and let's see how you did. All right, so remember the first thing that we want to do is start by finding our rate of change. And notice when I do this, I'm going to go from point to point, so I go up 2, and then I go to the right 3. So we know our slope is 2 over 3, rise over run, change in y over change in x. Now remember, you have 1, 2, 3, 4, 5 clearly labeled points on this line. So that means there's 5 correct answers you could pick. If I pick this first point right here, that point, all right, is -1, 4. So if I write that equation, it would be y equals 2/3. And then remember, the minus is part of our formula. So then x minus -1 becomes an x plus 1, and then plus 4. And so there's a correct answer. Some of you might have picked this point, right? And that point is 2, 6. And that would have been fine. And your equation would have had the exact same slope, and then it would have been x minus 2 plus 6. All right, and then notice it would have changed for any of the other points that you would have or could have picked. All right, so now that hopefully seems very familiar to you. Now what our goal is how can we take this information, right? So how can we transfer your knowledge of writing equations from graphs to writing equations from table? Well, here's the great news. What we need has not changed. So if we're going to write the equation of a line, we still need the rate of change, all right, or the rise over run, and we need a point. So what we have to do right now is transfer that into, all right, what we know, or transfer it to what we know about a table. So now let's look at our table here. And we've already done this a lot this semester, so hopefully this is really starting to, all right, fall into place for you. So what we want to do is, anytime we have a table, we always want to scan for a turning point first, because that's going to cut things in half, right? So when I look at my table, all right, I do not see a turning point, all right? If I do see a turning point, I know it has to be absolute value or quadratic, which is why we want to look for it. But no turning point really only eliminates absolute value. So now we want to go into those rates of change. And notice my first x changes by going up 3, then I go up 3, then I go up 3, and then I go up 3 again. And now when I jump over and look at my y's, I can see that each y value goes up by 2. And so I can see that I have this constant rate of change, 2 over 3, 2 over 3, 2 over 3, 2 over 3. And because it's a constant rate of change, all right, with no turning point, we know this is a linear function. So we know this is a constant, right, of 2 to 3, all right? And that tells us, right, this tells us that we know it's linear, all right, which tells us, right, that we need to use this form to write our equation, all right? And then notice, because we know it's linear, I can pick any point in this table, all right? And it does not matter. So typically, all right, just pick whatever you want. I'll just pick the point -4, 2. And then we take that point and we take our rate of change and we write the equation just like we did above, right? So we go back to our blueprint, which hopefully you all have memorized at this point, and if not, get to know that because you will need it to be memorized. And I take this information and I plug it in. So y equals 2/3, and then x minus -4 becomes x plus 4, and then plus 2. And there's our equation. All right, so it's the same process of what we've just completed in Unit 2, all right, but we just have to find that information in the table versus finding it in our graph. All right, let's flip the page and let's do this in steps together. So let's look at problem 1 here. All right, so what I want to do is just kind of go back and forth here a little bit, all right, to have you do a little bit of work. So what I want you to do, all right, is find the rate of change in this table, all right, and then think about what kind of function it has to be because of that rate of change. So pause the video, find that rate of change, and then turn it back on. Okay, let's look at what we have in our table here. So hopefully you saw that all of the x's are increasing by 5. And then hopefully you saw that all of the y's are increasing by 1. So we have a constant rate of change, right? So we have a constant of positive 1/5, no turning point, right? That means it has to be linear. Now, I'm going to keep reviewing that with you because eventually we're going to get to where all the tables are mixed up, right? So even though you might know that it has to be linear because of the way the lesson is set up, we still want to go through the same progression every time. Okay, so look for the turning point. Find the rate of change. Okay, then you should know what kind of function it is, and then you should be able to write the equation. Now, because I know it's linear, I can pick any point in this table. So I'm just going to take that first point there, which is -8, -6. All right, and then once again, remember our blueprint, which is that guy. All right, so I'm going to plug in my rate of change, which is a 1/5 this time. All right, and then I'm going to take that point, x minus -8 becomes a +8, and then -6. And so notice there are 1, 2, 3, 4, 5 correct answers because there's 5 points that you could possibly pick. All right, what every one of those should have, right, is the same slope of 1/5. All right, so that is all for that part. So now let's flip to the next page. All right, and let's do a little bit of work with absolute value. So now let's look at standard 6.2. I can write the equation of an absolute value function from the table values. Okay, now once again, we're going to try to translate everything that we already know about absolute value in writing their equations from a graph to a table. Okay, now let's review our form here. Okay, so once again, A is our rate of change, right? And what we know, right, is that an absolute value function has a constant rate, right? But we get those two, all right, directions, plus or minus, right? Constant, plus or minus, all right, and then we have our rise over run just like we did before. Okay, so we get that constant plus or minus, right, whatever it is, 3/2, those kind of things, right? Now, with an absolute value, remember that HK is something specific, right? HK, right, is the vertex, right, or the turning point, whichever phrase you like to use. So we have to use the turning point when writing the equation of an absolute value function. All right, so let's go and look at an equation here from a graph. So once again, just like we did before, I want you to pause the video. I want you to write the equation, all right, of this absolute value that's graphed here. Flip the video back on and we'll see how you did. All right, now hopefully all of you identified the vertex in this is -1/4. So we have to use that vertex. Now let's talk about the rate of change. I go down 2 and I go to the right 3. All right, now we have the plus or minus here. And what we know based on what we've discussed is that if the absolute value graph opens down, we want the negative rate of change and not the positive rate of change. If it opens up, we know A has to be positive. If it opens down, we know A has to be negative. So since this opens down, we know A has to be the negative rate of change. And now if I take that and plug it back in, there's my A value, it's -2/3. And if I use my turning point or my vertex, -1/4, I get inside my absolute value bars, all right, x minus -1 becomes +1 and then +4 like that. And there's our equation, right? And remember, you have to have the absolute value bars because that's what makes this equation an absolute value equation. So now, once again, if we're going to write the equation from a table, we still need all of this information. We still need to find the turning point. We still need to find the rate of change. All right, so now let's do that. Now, once again, all right, I'm going to scan my table and look for a turning point first. And notice I see that -1/4, all right, is my turning point. So even though we say find the turning point second, we're really looking for that first because that's our normal progression, all right? So negative 1, 4. Now, because I have a turning point, I know this is either absolute value or it's quadratic, and I want to go back into the rate of change, all right, and see what I get. So let's look at the change in our x's here. So it goes up 3, up 3, up 3, and up 3, all right? And then my y's go up 2, up 2. I hit that turning point, so we know it's going to change directions, and notice now I go down 2 and then down 2. So what we know, the rate of change is a constant of plus or minus, all right, 2/3. All right, and so what we have to do, and this is where it's a little bit more challenging in the table because we don't have the visual here, all right, to see whether it's opening up or down. But we can think about the rate of change. So notice when it opens down, it goes up and then down. So we have a positive rate of change and then a negative rate of change. So when I look at my table, notice I start with the positive rate of change. So when we talk about this part, think about the rate of change to determine which way the graph opens. And a quick sketch will help. So notice I have a positive 2 over 3, a positive 2 over 3. So what that is telling me is that it's going to go up first. It's going to hit that turning point. And now notice I have a negative rate of change. So that means it's going to have to come back down. So it goes up and then comes back down, which means my graph opens down. So when I think about my constant rate of change, or plus or minus 2/3, what I know is I want the negative 2/3 to use in my equation. So y equals, and once again, if we think about, all right, our form of an equation, which hopefully you have memorized, all right, I know I want the negative 2/3 this time, all right, based on my sketch, and then x minus negative 1, and then plus 4, and there's our equation. So notice we get everything from the table, all right, that we need. We just have to find it in a little bit different way. So what we're asking for doesn't change. How we find it does. All right, let's do one more problem together here. So let's flip the page, all right, and then look at the summary here. If your rate of change increases then decreases, then your graph will open down, okay? And the rate of change will be negative. If the rate of change decreases and increases, then your graph will open up and your rate of change will be positive. Now, you don't have to necessarily memorize that. You can just sketch the graph based on what you see. All right, so let's look at problem 3 here. All right, so once again, all right, I want you to pause the video. All right, and I want you to do two things. I want you to look and see if you can find the turning point in the table, and then I want you to find the rate of change. All right, and then flip the video back on and we'll see how you did with those two things. All right, so when I scan this table, I can see that I'm going 7, 4, 1, and then back up to 4 and 7. So I can see that I turned at 2, 1. So I know my turning point is 2, 1. That also now tells me that I'm either dealing with an absolute value function or a quadratic function. So the rate of change is going to tell me which one it is. If it's constant, all right, it's absolute value. If it's not constant, we know it's going to be quadratic. So notice, all right, oh, my table is backwards here. I'm not sure why that is. I'm going to change that here. It should be 0, 1, 2, 3, and 4. All right. So 0, 1, 2, 3, and 4. I'm not sure why it's reversed. All right. Hopefully it's not reversed on your paper. All right. So 0. All right. So my x's are going up by 1 here. All right. And then notice my y's. I go down 3. I go down 3. Hit that turning point. I go up 3. I go up 3, all right, and there you go. And so I can see that I have a constant rate of change. So it's a constant of plus or minus, all right, 3 to 1. Now, once again, which way does it open? And so that's where we're going to do. So notice I have a negative first. So it's going to go down, hit the turning point, and then it goes back up. So negative rate of change, so it goes down, positive change, it goes back up. So that tells me I need the positive, all right, rate of change. So y equals positive 3 over 1 and then x minus 2 plus 1. All right, so there's our introduction to writing equations from tables. All right, we'll do a little bit more practice in class. All right, so have your notes and everything ready, and I will see you next time.